Okay, good afternoon everybody. This is Bart from multirotorforums.com, and the purpose of today's video is to show how to convert a 2-axis camera mount to a 3-axis camera mount using just this module and a couple of other small things. So what you'll have is you'll have a single operator helicopter with a 2-axis camera mount, and we're going to configure it and set it up so that you can use that same helicopter as if it were a 2-person operation and a 3-axis mount. So this module is what's called a 4-channel servo multiplexer. It's from pololu.com, and we'll have links at the website and in the thread where the video is going to be posted. But to give you an idea of the size, here is an APM 2.5 module. Okay, here is a microcopter flight control 2.5, and here is a KK 2.0 board. So you can see this module is pretty small. And just to give you a little background, about 2.5 years ago I had the idea that I wanted to use my single operator photography helicopter with a 2-axis mount. I wanted to be able to convert it to a 2-person operation for the few times that I would want to shoot video. And rather than add a pan axis to my camera mount, I thought there could be a better way to use the technology that's already in the helicopter to create that panning motion and to be able to hand it off to a second operator. And that's fundamentally what we're doing here. We're using a 2-axis mount. We're going to use technology, software that's already built into the helicopter's capabilities, and we're going to use that to enable the helicopter to be set up for a second operator and a full panning motion of the camera. So originally, when I had planned on doing this, I worked with an electronics developer, Rob Ritchie from SmartFly, and he designed and built this prototype for us to test out, and it worked perfectly. It's got some firmware in there that has protections for bad channel switching and everything. We thought this was going to be the ticket and a pretty popular item, but right about the time we were thinking about going into a first production run, I was on pololu.com looking for a switch for something else and came across this. So this costs $10 along with a $15 orange receiver, a DX6i radio that you can get secondhand in the classifieds anywhere on the internet for about 80 bucks, and some wires. That's all you need to set up your helicopter. Now we're going to talk about what the flight control system has to have, and I'm going to talk about how this all gets wired and set up. But for now, let's look at a couple helicopters, and I'll show you more clearly what it is that I'm talking about doing. Okay, so just to make it a little bit clearer, we're going to explain what we're trying to accomplish with the module that we showed in that first clip. And what we're doing is we're taking a helicopter like this. It's a basic quad, has a DJI A2 flight control system. It weighs about 7.5 to 8 pounds. It's a little bit heavier because I have 2 big batteries and slightly larger motors on it. But we're trying to take this helicopter, which is more or less a dedicated single operator helicopter with a 2-axis camera mount, and we're trying to give it the capabilities of a helicopter like this one. Now, this helicopter is a lot more expensive to build. It's not as easy to operate when you're trying to use it in single operator mode. This is more like what you would have for a dedicated 2-operator helicopter with a 3-axis camera mount. And the capability with this that you don't have with a basic quad in a single operator mode is that while the helicopter is flying in one direction, the camera operator can be completely independent of the helicopter, following an object moving in the opposite direction. That camera operator can be panning as the object goes by, also tilting as it gets farther or closer to the helicopter. So the kinds of motions you can do with this in 2-operator mode, they're very complicated. The cost to build a helicopter like this, though, and the commitment with the 2 radio systems, the requirement of having a second operator most of the time, it's a big commitment to make if you're not really ready for it. But there's a lot of helicopters like this floating around, and you'd be surprised how good the footage can be. Now, this helicopter is part of a product review. The camera mount is being reviewed at multirotorforums.com. It was supplied by GotHeliRC.com. They were very generous in donating the camera mount to this build in order for us to complete it and do a review, as well as this video showing our 2-axis to 3-axis trick. So here's what we're trying to accomplish. Normally, when you're in one operator mode, the helicopter is going to fly, and you're either going to point the camera and the helicopter using a rough guess based on line of sight, or what I have a set of old goggles from my view which allow me to look down and see the camera while also flying line of sight by looking out over the goggles. So I use those when I'm in single operator mode, and I can get pretty good results, but between flying the helicopter and trying to track a subject, I can't get very complex with my motions, and I can't be very creative with how the shot's being composed. So in single operator mode, if I want to follow a subject, the whole helicopter has to move in order to follow, in order to pan the camera, and then tilt is something that I have to do on the radio while I'm also flying. Now, a lot of times that's great to have, that's all I really need, especially when I'm out doing photography. That's all I need from the helicopter. But when I want to do video, when I want to have a second person contributing to the process, I either have to bring a second helicopter, or I can wire it up using that module I just showed you. So here's what we're trying to do. In order to make, here's an old camera mount, old servo driven mount. This is one of the ones that I designed a while back and I was using quite a bit. But in order to make the camera mount pan, you have to build a third axis in on top with another brushless motor and a more sophisticated controller, so the camera mount underneath the helicopter can move. But the helicopter already can do that motion. It's called yaw. So what we need to do is figure out how to fly the helicopter without yaw, so we can hand it off to a second operator so they could then yaw the helicopter as if they're controlling the camera mount. So if you can do that, yaw and tilt are the two basic controls for the camera operator to use, and if you can live without those, then you can keep flying and you have a two-person operation. So there is a mode that allows you to do that, and most of the modern flight control systems have it. It's called Carefree mode, or intelligent orientation control. So in that mode, the helicopter becomes a point in space, and you fly it as if it's just a point in space, and what you're doing with that right stick is you're just slewing the helicopter. You're not really flying it anymore, you're just moving it around in the sky, front, back, left, right. And when you're in that mode, the heading of the helicopter no longer matters. When you push forward, let's say the helicopter's pointed in this direction when you first power it up, that's going to be forward. Anytime you push the right stick forward, the helicopter is going to go in that direction. If it's pointing in this direction now after it started up, it's going to tilt in order to fly. So read your manuals, we'll discuss it online, but Carefree mode allows the helicopter to be pointed in any direction and still fly the same relative to the first operator, the pilot. So when you switch to Carefree mode, you hand over control of yaw. Yaw becomes pan for the camera mount, and you're also handing over tilt, and that's what that module allows you to do. It allows you to have one set of inputs that go through the board out to the flight control system, a second set of inputs that can go through the board out to the flight control system, and then it uses a switching channel to decide which set of inputs are going to be sent to the flight control. So when you're in single operator mode, you're flying, you have control of yaw, you have control of tilt. So the helicopter, the camera mount, it's all your responsibility. When you flip the switch to Carefree mode, or intelligent orientation control, what's happening is you're giving up control of yaw, you're giving up control of tilt of the camera. A second receiver that's going to be on the helicopter is going to be switched on, and now the flight control system is going to listen to those inputs so long as you're in Carefree mode. So at that point, the camera operator now could be wearing a full-blown set of fat sharks, completely oblivious to what's going on around him or her, and controlling the panning of the camera and controlling the tilt of the camera. And I'm going to say this over and over again. I'll show you guys in video once I get this helicopter up and running, or I'll try to dig some other stuff out from my hard drive. It works great. You'd be surprised. And a helicopter like this, you can do this trick. You can use it if you're trying to save money and you want to fly a helicopter like this instead of something much more expensive. You're not giving up a whole lot by making that decision. If you have an FPV helicopter with a 2-axis camera mount, well, you know what? If it's got a GoPro, you want to take it to a soccer game, all of a sudden you can hand over control of the camera. On your FPV, you know, your little fun flyer, you could do much more sophisticated work with it once it's set up like this. Another thing, you know, I've used a small helicopter like this to choreograph shots. So I'm taking this lighter, less expensive helicopter, much easier to operate, and I'm practicing shots, trying to visualize what's going to work, trying to get footage that I can look at so I can see if my ideas are working before we take the heavy, much more expensive helicopter up flying with the more expensive camera. So there's a lot of uses for this trick. If for nothing else, you can take a helicopter like this. You could take your F450, maybe one that you built as part of our group build last year. This one's set up for straight for FPV. It doesn't even have a camera mount on it, but you might have one of these with a Taro gimbal, with one of the other gimbals you get on eBay, 2-axis. Excuse me, the switches that we're adding, the wires that we're adding, the little receiver, the weight is it's marginal. It's negligible compared to the rest of the weight of the helicopter. So almost any helicopter can be made to function the way a more sophisticated 2-man rig would with a 3-axis camera mount. So in this next segment, we're going to take a look at the electronics. We're going to show how the wiring works. This is not going to answer 100% of your questions. This is my 3rd time trying to do this video. It's a confusing thing to explain to somebody, so we're going to finish the video, put it in the thread, and then host the conversation at multirotorforums.com. I'll be happy to answer any questions. All right, let's show how the modules get hooked up with the receivers on the helicopter. Okay, so we've already showed you with the 2 helicopters what the fundamental operation is here that we're trying to accomplish. We're trying to accomplish a switchover of 2 control channels related to movement of the camera. We're trying to have that swap over happen when we switch the controlling radio, which is going to be this one, from normal flight modes to Carefree mode. And on this radio, the way I set it up for DJI is to use this switch right here for my 3-position IOC, Intelligent Orientation Control. So when I flip this to the 1st or 2nd position, both of those are what we would call Carefree modes. Carefree is a mode that Hoverfly and Microcopter used. That was what they called it. So you'll hear me go back and forth between the 2. But when I'm going from normal flight modes to Carefree, it's this switch. And so the first step to wire up your system to use this board is to, and I'm just using this as an example. Here's my receiver, and here is a generic Futaba S-Bus encoder, and this is actually from Zero UAV. So this would go to my A2 flight control system. That's the helicopter that I'm building right now, where I'll demonstrate all this once it's done. So what I'm going to do is I'm going to take the channel that would be for Carefree mode, and I'm going to unplug it, and I'm going to install a Y connector. So you need a Y connector that has, if you were going by the plastic, these would be 3 male connectors. If you were going by the metal part inside the plastic, these would be female, depending on what your nomenclature is. But what you need to do is install a Y where you're going to run control for the switching channel for Intelligent Orientation Control, or Carefree. And the reason you're doing that is because that's going to be the signal that switches the module. And the module has inputs for 2 different receivers, as well as 1 input for a switching channel. And I'll also post photos online for this. But you'll be able to see that uppermost corner there with grounds located along the outside. That's where you're going to plug in the Y that has your Carefree mode. Okay, so now once you do that, switching this channel on the radio causes this module to select either the master or the slave inputs, and it uses those for the 1 output. So once you have that done, you're going to take the number 1 and number 2 outputs, which are in the opposite corner, again with grounds along the outside. You're going to plug in 2 servo wires that we would normally use for control, and we're going to run those to our flight controller in the yaw and camera tilt channels. And I don't know if these positions on this encoder match up. I'm just kind of doing this to illustrate how this is going to work. This is an extremely confusing thing to try to explain. This is about my 3rd time trying to do this video. So we're going to put this all into the video, put it into a thread, and we'll be able to discuss it freely, answer whatever questions people have that want to give it a try. So you've wired up the switching channel to the selecting prongs, the one selecting channel, and then we've got our master outputs going to the flight control system. Okay? Now what we want to do is put in our 2 sets of inputs. So the first one we're going to do channels, everything is going to be channels 1 and 2 if you're only going to use pan or yaw and tilt. There's up to 4 channels that can be switched, although you'll see it gets reduced to 3. But the master channels are 1 and 2. Okay, so we'll plug this in. Some more wires. We're basically just taking 2 sets of inputs, selecting between them to send an output to the flight control system. So number 1 is going to be yaw, and that'll go in the rudder from the receiver. And channel 2 is going to be camera tilt on the first radio. Now, when this module is not switched, when it's in its master mode, which is unswitched, this receiver is going to send yaw for the helicopter and tilt for the camera mount through the module into the flight control system. When this switching channel is switched, these 2 channels are going to be disregarded, and it's actually going to switch over to these inputs. Those will then go to the flight control system, and a second radio, this one over here, will control pan and tilt. Now the pan, like we said earlier, is going to be actual yaw of the entire helicopter. It's very stable. You'll be surprised how well it works. Tilt is going to be the same tilt function that you had with the radio. On this radio I tend to use the slider over on the left side with my pointer finger for tilting the camera. On a second operator's radio, depending on how the camera mount works, if the camera mount's tilt follows absolutely the position of the stick, then you would use the throttle stick. If the tilt of the camera mount moves according to how far out of zero or out of center the stick position is, you would want to use the elevator channel. So we've got this wired up. We've got the first set of inputs, the switching channel, and then the 2 outputs. Now what we want to do is take our second receiver and take the throttle. I set mine up to use the throttle stick for the camera tilt. So that'll go, I'm sorry, the yaw of the helicopter is going to be slave channel 1, and the grounds are always on the outside with this module. And then tilt of the camera mount is going to be slave channel 2. Now, this is an important point. So this channel, this side of the module over here, is powered by the power coming into the system through the ESCs or through a BEC. Whatever you're using to power your receiver, that's going to be brought in via the red wires. Okay, but there's no transfer of the power from this side to this side. The grounds transfer. The grounds are all common on the board, but the red center wire, that 5 volts, does not transfer. So what I do is I have a very short servo wire, and I use channel 4 as a jumper to jump power across the board to the slave pins. And what that does is it brings power over to these pins and sends power to the receiver. So that also powers my second receiver. Okay, so by installing this on your helicopter now, with a little bit of configuration work, you're pretty much set. If you have a good helicopter, you know, we said this earlier, if you have a good helicopter that's tuned, that's stable in yaw when you're flying it, that has the ability to do Carefree mode. Installing this is going to give you virtually the same performance as a dedicated 3-axis camera mount. Now there are obvious shortcomings. You're not able to fly the helicopter exactly the way you might fly it otherwise, so you're going to have to learn some strategies for dealing with that. Also, a dedicated 3-axis camera mount with a retractable landing gear probably gives you a little more flexibility, but if you go out there and try this, you're going to find that I would wager 85% to 90% of the capabilities can be matched doing this with a little bit of trial and error. So give it a try, you'll be surprised. And like I said earlier, any simple helicopter with a simple 2-axis camera mount, provided you have a discrete output where you can tap in and switch your Carefree mode and your channels and stuff, you'll be able to adopt this. Alright? So let's post this online. We'll talk about it in the thread. If you have any questions, if you need further explanations, we can cover it there. The one step I haven't done yet that I will post in a separate video is how you train this module. It has a training mode, and how you train it to know that the movement of this switch is supposed to make the switch do its thing. And that's a training mode. It's a little bit tricky. There's 2 exposed pads right there that you have to short as you give power to this, but it has to be installed for me to be able to do that. Alright, so that's our 2-axis to 3-axis camera mount conversion using a Pololu 4-channel servo multiplexer, available for $10 at pololu.com, Pololu.com, and we'll see you at multirotorforums.com. We'll discuss it, we'll post some samples. I'd love to see your samples, and I'd be happy to answer whatever questions you might have. Thanks again for watching.